I used to have Unit 4, as it says on your paper, miscellaneous organic, and it encompassed a whole bunch of stuff. But over the years, it got absolutely ridiculous. Look at the size of this folder. I've got all this crap in here that I no longer can fit into one unit. So I've decided to break it up. This is the first year I'm doing it, into 2 units. So instead of what it says there, you're going to write down polymers. I'm going to do the polymers and biochemistry first. Now, polymers...
Poly means.
What does the word poly mean?
Many.
Many. All right. So many mers. Many mers. I'm making fun of you. All right. They're large organic molecules formed from large chains of smaller units, and these smaller units are called monomers. All right. And the thing is, I used to just do a very short section on this, and maybe like 1 day of notes and maybe 1 day of labs. And I've expanded it over the years. So I'm going to classify the polymers in different ways. And when we talk about natural polymers, I'm going to spend a lot of time, starting today, talking about some of the natural polymers in your body or in living things. So I'm going to call this biochemistry in a way, because a lot of your body's chemistry is polymers. Okay? A lot of biochemistry is. So basically, I can classify polymers in 2 ways. And I can classify them in 2 ways that can overlap. All right? I know there's not a lot of room there, but I had to squeeze this onto 1 page when I redid the notes this year. All right? I made the pictures a little smaller. I have a lot of these pictures. You have to remember, before I put all these pictures on your notes, I had to make you guys draw these. That was like a long time ago, but I'm just saying, you have a lot less writing to do than people had to 20 years ago. In a sense, that's not necessarily a good thing, because when you draw something, you kind of remember it a little better, but still, those pictures are there to help you. All right, the same picture is going to be up here. And you don't have to actually draw them out. All right, I'm going to classify polymers in 2 ways, condensation or an addition, or natural versus synthetic. And these 2 can overlap. All right, I can have a condensation polymer that's natural, or I can have a condensation polymer that's man-made. And vice versa. Addition can be natural, addition can be man-made. So it's not like they're mutually exclusive. But there are 2 ways I can classify them, and I'm going to start with the natural. All right, let's start with natural polymers. Natural polymers. All right, and we're going to do, I actually rearranged these so I could fit them all on 1 page, and I do them in the right order so I could do my thing. Here, hydrocarbons, you might be surprised to find that rubber is actually not man-made. I mean, you can actually make natural rubber, and it comes from, and people in their class, Katie's class, had a really hard time not laughing at this. Where does rubber come from, Katie?
Trees.
Oh, yeah, rubber trees.
Yeah.
Rubber trees.
Wait, is that real?
Yes, it's real. That's the point. That's why I say people like in that class where I don't know if you were here that period, maybe not.
Wow, can we look up what those looks like?
Yeah, they bounce when they fall over. They bounce back up.
Latex.
Just kidding. Yes, the sap of the rubber tree, just like the sap of a maple tree. If you take sap out of a maple tree, anybody do that? Anybody ever tap the maple tree? Okay, Katie has, being the woodsy girl that she is. She's like a Duck Dynasty. Okay, well, I thought maybe she was out in the woods. Close enough. Okay, the sap from a maple tree, if you boil off or if you let it evaporate off all the water, you end up with maple syrup. Well, the sap from a rubber tree contains latex, and when it hardens, you get basically rubber. And you are going to use. I hope anybody know they're allergic to latex, by the way?
No.
Right, because in the lab, we're going to do. It's pretty funny. In the lab, you're going to make a rubber ball out of latex.
Can we keep it?
Yeah. Now listen. Okay, we got 1 fan over there. What you're going to see, but listen, it's funny because it's obviously made from latex, right? And so you say to yourself, I used to tell people, so if you're allergic to latex, here, put these gloves on. Of course, what are the gloves made out of? Made out of latex too. So it was kind of a waste of time. Yeah, it was very funny. You can all stop laughing now. It was hilarious. All right. So yeah, we're going to make, by the way, we're also going to use guar gum. Now, if you look at a lot of the ingredients, in particular of gum, but if you look at a lot of the ingredients, you do use guar gum to thicken things, and in particular, it's in gum. And we're going to use that to make slime. We're going to make 2 kinds of slime, and you're going to get to keep all of these when we do that lab. But that's not for a while, because we want to talk about some other natural polymers, And we're going to go through all of the polymers before we get to that lab. So it's going to be sometime maybe Thursday we might actually get to that lab, Wednesday or Thursday next week. All right. Here's a picture of the rubber monomer, okay? You take this guy, and what a monomer means, by the way, get used to seeing this. A lot of times when you're showing polymers, I was redoing your worksheets, polymers will have a bracket around them with a line coming out, which just means that what's coming off of this side is going to be another one of these guys, and another, and another, and another. It'll be thousands long, and that's...
Poly means many.
Poly means many. Now take a look. The rubber ball you're going to make is not going to be very useful. All right, you couldn't use it to make sneakers out of it. You couldn't use it to make tires out of it because it's too sticky. It's not very durable. It's too soft. So you heat it with sulfur around, and that's called vulcanization. And what happens is these guys, that's rewritten a different way. These chains are cross-linked with sulfur, and what you end up getting is a much more durable rubber that I could use for the bottom of my soles of my sneakers, or I could use for my tires. All right, and it's called vulcanization because you're heating it in the presence of sulfur. All right. Okay, so there you go. That's basically hydrocarbons. Let's talk about the next one's polysaccharides, another natural polymer. You say, well, what do you mean polysaccharides are a polymer? They are either in your bodies, and they're in plants, and we basically need these to survive. We have to eat polysaccharides. What's another name for polysaccharides?
Starch.
Well, starch yeah, like a saccharide or a carbohydrate. They're carbohydrates, basically. Carbohydrates is a generic. It's a very large, encompassing term. It means anything that's carbon that's been hydrated. See, carbohydrate. So sugar itself, glucose. What is the formula for glucose? Think of this. What's the formula for glucose? C6H12O6, which is basically CH2O, isn't it? Right? Don't write that down. I'm just saying. That's a carbohydrate. And if I have a whole bunch of these guys together, whether he's a monosaccharide or a disaccharide or a polysaccharide, they're all carbohydrates. All right? And we need these. We need to eat these. We need, obviously, the sugar. Where does the sugar go? Sugar goes into the Krebs cycle, and it gives us energy, right? We get ATP out of it. This is, by the way,
this is not biology, it's chemistry.
This is bio, and it's exactly where we're going with this. We're going to have, this is called biochemistry, and we are going to have a lot of biology over the next couple of periods. All right? Now, look at carbohydrates. All right? Carbohydrates are just basically any of those. They could be any length, 1 or 2 or 1,000 long. All right, but we have special names for the ones that are longer. All right, we call them polysaccharides. All right, and one of the most famous ones is starch. Okay, starch is the edible or digestible form of a polysaccharide, the digestible form of sugar in plants. That's what they do. By the way, we don't make starch in our bodies. We can store sugar in a couple of ways. What's our equivalent of starch in our bodies? Anybody know that from biology class?
ATP.
No.
I don't remember biology.
Well, you should. It's glycogen. Glycogen is the animal equivalent of starch. Okay? Well, it is.
Yeah, I've heard it before. I'm the only one that's one.
Cellulose. This is the funny thing. The difference between starch and cellulose, you're going to see in a second. Cellulose is the non-digestible or inedible form of
Indigestion.
sugar. And it will give you indigestion if you eat it. But a little bit of it's good for you. What is the difference between starch and cellulose? It's very simple. It's their structure. Take a look at that structure. Can you see the difference between those two?
Absolutely.
They're exactly the same,
They're flipped.
but they're flipped. Every other one is flipped. By the way, remember, this is going to be many sugars long, not just 3. This continues. All right, but every other one is flipped for cellulose, and they're not for starch. This is the difference, Lizzie, between eating starch, eating pasta, and eating paper, because that's what cellulose is, right? You want to eat paper? Not going to get much energy out of that. However, we do need some paper in our diet. We do need some cellulose in our diet. What do we call it? What do we call that stuff in our diet?
Cellulite.
Not cellulite, no.
Fiber.
Fiber. Let's talk about this next one, which is going to bring us to the reason I'm going to do a lot of biology, which is one of Bulkley's favorite things to do.
It's actually
Polypeptides. What is polypeptide referring to?
Many peptides.
What would they be? What's another name for a polypeptide? If you put a bunch of peptides together, amino acids together, what do you get? What's the name for that thing with a whole bunch of amino acids linked together? Exactly. Basically, that's what we're going to spend the next 2 days on. The second period today and probably all of Monday are going to be spent talking about how you make proteins. All right? Because they are a very complex arrangement of amino acids. They're the monomer. The monomer in this case is an amino acid. And depending on how I arrange them, depending on how many I have and how they're arranged, I will get every possible protein in your body. You know, proteins do a lot of different things. Your muscles are made of protein. They have different proteins that make, give you your eye color. They make your skin, make your hemoglobin in your blood, insulin. All these things that keep you alive. All the chemicals there. It's all about proteins. All right, and you know how they're built by messenger RNA from DNA. In transcription and translation. And guess what we're going to talk about for the next 2 days?
RNA.
Promise me we're not watching Bamboo Guys.
One last thing before we finish up here. Take a look. All right, here's the key to an amino acid. You have this picture here, but watch this. I don't want you to label this on there. Watch. Label this. Notice, now that we've had organic, this makes more sense to us. This side over here, the C-OH, that's a carboxylic acid group, isn't it? So that's the acid part, right? And on the other side of every amino acid is this part. What do we call that from last chapter?
Amine.
That's the amine part, the amino part.
Amino acid.
Yeah. There you go. Now look at, notice these are two different ones. And where do they join? The acid part and the amine part join here, and they can link. But guess what can happen? A guy on the other side can link here and there, and they continue to do it. The only difference between the amino acids, there's about 20 amino acids that your body uses, some of which are essential amino acids. We'll talk about that. The only difference between the amino acids is this part, the R group. The R group for this guy is just 1 carbon long, but he could be multiple carbons long. He could even be a ring. He could be a lot of different things. So depending on how many carbons you have here, that's what tells you what the actual amino acid is. This guy is glycine. But it could be leucine. It could be any one of the 20. I'm not going to make you memorize, but I don't know if you ever had to do even for bio. Anybody ever have Bio 2 AP Bio in here? No? Okay. Well, I don't know what you're going to do in that class. You might. I mean, it's possible you'd have to know all of the amino acids. And, I mean, in college, certainly, you probably have to do more of that kind of stuff. But for me, I just want you to understand the reaction and how they're made. And that's complicated enough, believe me. That's what I'm going to be doing with you the second half of the next second period here. All right, but I'm going to stop it here.